Good morning, everybody. All right, so I'm back again, and this is another pre-recorded lesson. You can still join our Zooms for any other miscellaneous questions you might have. Just won't be a live lesson. Obviously, you guys have seen these have been posted, sent out already before our regular Zoom, but that's okay. So you guys can watch them first thing in the morning or in the evening, whatever works best for you. So day 2, some actual assignment questions of what we went over. So I'll write down the formulas, but remember all those different formulas, there's 3 different types of dot products. There was algebraic, geometric, and our projections. So keep them handy. My first one here, this is going to be an example of an algebraic. Well, how do I know that? Well, that's because I'm going to go ahead, I'm going to say this is my U, this is my V, and I have the 2 dot products. If I know the 2 are the 2 vectors, then I could just go ahead and use my algebraic dot product. And what that tells me is U dot V is equal to U1 V1 plus U2 V2. So for this, my U dot V is just going to be -3 times 7 plus my 5 times 8. And I go ahead, I clean that up. I get -21 plus 40, which is going to give me 19. And I'm done. Check. Simple as that. This is my favorite way to do it. It's super easy. You guys get used to it. And it's probably the most common. Use it for when we do finding our angles as well. Remember, it's a dot product over the magnitudes. So that was very common. Okay. Oh, here we go right now. Oh, they already gave us a dot product. We didn't even have to solve this out. This one's going to be easy peasy. It says find the angle. So we're looking for theta. And on Friday, we were given that theta is equal to cosine inverse of, and we're using R and S. So we used the U and V the other day. They're just variables. So I'm going to do R dot S all over the magnitude of R times the magnitude of S. If I don't know those values, then I would have to figure them out. Here, they told us the magnitude of R and S, and they told us the dot product. Perfect. All I need to do is plug it in. So cosine inverse of 125 all over my 16 times 9. I plug this into a calculator. It's in degrees. Your calculator should hopefully already be in degrees, but double check in case it's not. And when you do that, you should end up with theta is equal to 29.77 degrees. Done. The next one's going to be a projection. I know that because of the notation. So there's 2 parts of the projection. So remember, the first part is going to be that my projection of A onto B is going to equal then the magnitude of A, so the bigger one, whatever's bigger, times my cosine of theta. That's step 1. Then to find the dot product of the projection, so A dot B is going to be my projection of A onto B times the magnitude of B. So I've got to start with this piece first, the projection of A onto B. So let's look and see, what do I know? It tells me that I have vectors A and B with given lengths, so the magnitudes, and it's telling me that the magnitude of A is equal to 21, magnitude of B is equal to 44. I like to write this info out so it helps me visually to see, well, what is it representing for when I plug it into my formulas. Then it says cosine of the angle between them is equal to 7/10. So cosine of the angle between them, so cosine of that angle is equal to 7, I said tenths, I think 7/12. So cosine of theta is equal to 7/12. Find the scalar projection of A onto B and A dot B. Let's go ahead and do it. My projection of A onto B is going to be the magnitude of A, which is 21. Cosine of theta is this whole thing. It's 7/12. So I could go ahead and I can multiply it out, and it's going to end up being 49 all over 4, which is going to be approximately 12.25. I probably would have gone straight to the calculator, but your answer choices are going to be written as your 49 all over 4. Personal preference, however you want to do it. You could simplify this right here too. You could see that 3 goes into both of them, so this would have been a 7 and a 4. So if you wanted to simplify it that way to get this easily, if you plugged it into the calculator, you got this, but that wasn't an answer choice. Of course, they're still equivalent. For my next step, I can use either number. So I'm going to go ahead, I'm going to use my 12.25 times my B, which is my 44, my magnitude of B of 44. So it's going to be 539. So here are the two solutions. Again, they use this notation. It's a drop down bar, so you pick the correct one. And this was my 539. All righty. Next one. Which set of vectors are orthogonal? What does orthogonal mean again? Are perpendicular. Remember, orthogonal means that they're perpendicular. And how do I know if they're orthogonal? They're orthogonal if u dot v is equal to 0. They are orthogonal if the dot product is equal to 0. So I'm going to go ahead and I'm going to solve the dot product for each one of these. So remember, multiply the first two numbers together and then add it to the multiplication of the second two numbers. So this is going to be -1 times 1 plus 0 times 0. That's just going to give me a -1. Does that equal 0? No. So is it orthogonal? No. My next one is going to be 1 times 0 plus a 0 times a -1. Of course, it's going to be a 0. Orthogonal. It equals 0. They are perpendicular to each other. My next one, -4 times 12 plus -6 times 8 is going to give me -48 minus 48. I don't need to go any further. I already know that's not going to be a value of 0. My next one is going to be 4 times 12 plus -6 times 8. So this is going to give me positive 48 minus 48, which is my 0. Yay! That one's orthogonal. My next one, 10 times a -10 plus a -5 times a -20 is going to give me a -100 plus 100 is equal to 0, orthogonal. The next one is going to be 10 times a -10 plus a -5 times a -2 is equal to a -100 plus 10, not going to be 0, so it's not orthogonal. So just figure out what is the dot product of them. Equals 0, orthogonal, they're perpendicular. Not equal to 0, they're not orthogonal. And our work ones. All right, so remember our work problems, joules. How did I know it was going to be work? It's because I saw the joules right away. Joules is going to be the units for work. And so we were given the equation for work is equal to the dot product of F times D, which is equal to the magnitude of F times the magnitude of D times my cosine of theta. So I could use either one of these. Either one of them, just depends what information did they give me, which one's going to be easier to use. So I look here and I go, a boat is being towed such that the tow line is at an angle of 30 degrees, an angle of 30 degrees with respect to the surface of the ocean. If the boat is towed at a force of 50 newtons, so my force is going to be, 50 newtons for 7,000 meters. So my displacement, that length, remember length is going to represent that magnitude. So for that 7,000 7,000 meters. That's that displacement, how much it moved from one spot to the other, that distance there. Approximately how much work is done? Well, I look here. I know the magnitude of F. I know the magnitude of D. And I know that my angle here is 30 degrees. So I'm going to choose to use this equation. And I plug in all the information I know. So I end up with 50 times 7,000 times cosine of 30 degrees. This goes into my awesome calculator. And I get 303,108. It says, oh, it's just saying approximately. So I look at my answers and I see that it's going to be approximately 303,000. So they rounded them all to the nearest thousand there. That's okay. You guys can see that you were super close to that value, and this is my correct answer. Tomorrow we'll go over a quiz. Again, still please feel free to join me at Zoom at 10:30 if you have extra questions or anything else that you might need. I will be on Zoom. I'm just not teaching a live lesson. I will start back live lessons tomorrow. So when we go over the quiz, I will be back live. You guys have a wonderful day. Take care.